Okay, in this video, I am going to go over segments and circles. So first off, we have three types of segments and circles. And it's similar to when we were talking about angles and circles. So we have type one or case one, where the segments intersect inside the circle, and that is going to basically be part times part equals part times part. That's what I like to remember. So that's made by chords or secants. And so we're going to do the two parts, C and D, and A and B. So A times B is equal to C times B. So it's part times part. And then for case two or type two, we have the intersecting outside the circle. So we have the case where it's two secants. So we've got both outside and whole thing and outside and whole thing. So I think ow, ow. So part times part. And then I think ow, ow. Ow. Outside times whole equals outside times whole. So the outside bit right here is A times the whole thing, which is A plus B. And that equals C, and then C plus D. And now the last case is where only one part is outside and the other part is inside. This is with the tangent. So I like to think of it as tangent squared equals ow. So tangent squared, which ends up being the whole thing, A squared equals outside times the whole thing, B plus C. And that's it. So we're going to do a couple examples of all of this. Let me see if I can get this guy a little thinner. Okay, so we're going to let's do the trickier one first. Let's find BD. So BD is this entire segment right here. Let's see if I can circle it or highlight it. To do that, we're going to do part times part equals part times part. So this is a part problem. 6 times 6 is equal to 4 times 5x minus 1. And then you just solve it. 6 times 6. And then distribute the 4. Add the 4 to the other side. 40 equals 20x. Divide both sides by 20, we get x equals 2. Not what I'm looking for. I'm looking for BD. So 5 times 2 minus 1. 10 minus 1 equals 9. And let's do, yeah, these guys. We can have some with like factoring and stuff. So let's do a harder one where we're just solving for x. So let's do one like number 3. So for number 3, again, part times part equals part times part. I don't know if we're actually going to be solving for x. Assume, yeah, so no, I think we're okay. 27 times 5x plus 5 equals 24, and yeah, we're okay. This one's not a factoring problem. And then you would do the same thing. You would distribute to both sides. 27x, and calculator right here, 5 times 27 gets me 135. And then 24x minus, no, that's a plus. Pay attention to the signs. 24 times 7 gets me 168. And then we just want to solve for x, so get the x's together. I'm subtracting the smaller one over 3x, and then I'm going to subtract the other side, 135, 135. I get 8 minus 135, 33. So divide both sides by 3, we get x equals 11, and then double checking that's what we were looking for. It is. We're good to go on the part problems. Now we have the ow problems. Ouch. So ow problems, I've got an outside bit times the whole thing, and then an outside bit times the whole thing. Doesn't really matter which one we pick. We can do one with distribution just because it's tricky. So let's do this one, 8. So outside bit times the whole thing. My outside bit is 12. My whole thing, what's 12 plus x plus 8? 12 plus 8 is 20, so that's x plus 20. That's it. Makes it unnecessarily simple, or it was unnecessarily hard without that information. Outside bit times the whole thing. So let's add these together. The 15 and the negative 1 gets 14. So that's x still plus, because the 1 was that way. Let's go ahead and plug it in over here. So we're going to distribute both of these guys together. Let's do a different color. Distribute the 12 and distribute the 15. 20 times 12 gets me 240. 15x, and then 15 times 14 gets me 210. I get 3x, and then 240 minus 210 gets me 30. And then divide both sides by 3, I get x equals 10. Okay. Oh wait, that's not what we were looking for. I'm glad I looked. We are looking for YZ. YZ is this bit right here. So my answer is going to be 10 minus 1, which is 9. So YZ is 9. Oh, I guess I can erase that bit. There you go. Okay. Let's look at another one of those. Going to up here. So we have, oh, these ones are tangent problems. They're fine. Let's do a couple of these. These ones kind of get confusing sometimes. Let's do 10. Okay. So Pn is what we're looking for. So we're going to plug back in and find that segment right there. Outside bit times the whole thing equals outside bit times the whole thing. The whole thing is the outside bit, so we just square it. 8 is my outside bit, the whole thing. 5x, and then combine the negative 1 and the 8. Negative 1 plus 8 is positive 7. Distribute the 8 to both terms. Believe that's 256. Yep, and then 8 times 5 is 40x. 8 times 7 is 56. Oh, that's 200, sweet. So subtract both sides by 200 or by 56 and we get 200. Divide both sides by 40. I believe that's just 5. And then plug in, yep, it is. Plug in to Pn. So Pn is equal to 5 times 5 minus 1. It's 25 minus 1, which gets me 20. Or my pen is skipping. 24. Cool. And let's do another one where we have the X on, I don't see that X on the outside. Oh, here's one where the X is on the outside. So this one might be a little tricky. Let's do 14. So we're solving for X. Outside times the whole thing. So outside is 4 times the whole thing. 4 plus 2 is 6. That's easy enough. Outside bit. Whole thing, however, is X plus 5. So when that happens, we're going to get 24. And then distribute the X, we gain a degree, X squared plus 5X. Now we're going to have to factor. Woohoo. Subtract 24 on both sides. And what multiplies to be 24 negative and adds to be positive 5? So I think 3 and 8. And I want it to be positive when I add them together. So I'm going to make the 3 negative. Negative 3 plus 8 does get you 5. So that does check out. And because my leading coefficient is 1, we can go straight into factored form. And so all we did was undistribute it. So it was distributed and simplified in this version, and this we just factored it. One of these numbers, when we solve for X, we get a negative. This guy gets you a negative, so it's going to be X minus 3 equal to 0. We get X equals a positive 3. So factoring, it's not that bad, I promise. Another factoring problem would be number 16, super duper fun. We have outside bit is its whole thing, so we're going to square it. So it's X plus 5 squared equals outside bit 12 times the whole thing. 12 plus 15 is 27. And then for squaring this, we can undo the square and just FOIL or double distribute, or you can remember that it's this number squared plus 2 times these two multiplied together plus this number squared. That's the little cheat code. It's a formula that always works out. But I'll show you why it always works out. X times X squared, X times 5, 5X. It's going to get you the same thing right here. That's where the 2 times these two together comes right here. And it always works out. And then 5 times 5. Common mistake, you just distribute the square. You're missing the middle 2 terms, which are the same thing. That's why you don't distribute the square. You actually double distribute. What does the square mean? It means it's multiplying by itself. The more you know. Add 25. And that is equal to 12 times 27. 324. Well, there we go. 324. Subtract the 324 over, so 25 minus 324. I get negative 299. Let me make sure that I did that right. 3 times 27, yeah? Yep, 12 times 27. Okay. Oh, I know what it is. There's not a lot of numbers that add to be 10. That's nice. So negative 299, and I'm adding to be negative 10. I'm going to use my calculator. 99. I don't know. It's not divisible by 3. looking at it, I need two numbers that are back to back. So I'm just gonna keep dividing. I tried 4, it's not 5. It's not gonna be 6 because it's not even. It's not gonna be 7. I just tried it. What about 8? Nope, it's not 8 because it's not even as well. And it's not divisible by 4. What about 9? No, because it's not divisible by 3. 10, no. 11, no. 12, no. 13, yes. Okay, so it's 13 times 23. Both of those numbers are prime. One of those numbers should be negative 23, and that would get you negative 10. Oh my gosh, that was such a mess of a factoring problem, but you just had to keep going until you got the factor, which honestly didn't take me very long. Coming down here to do this problem. So my factors are 13 and negative 23. So I'm going to do x plus 13 and x minus 23. Because it's equal to 0, we're going to set it equal to 0. Again, this guy is going to get you a negative 13. So negative 13. That's not possible in this example because that would get us a negative tangent when you plug it back in. Add the 23 over, we get 23. 23 is acceptable, and I want to make sure what I was asking for x. If it was asking for you to plug it back in, you would just plug it back in right there. Okay. See, it's not that bad. It was fun, right? Okay. Have fun with these problems. Bye, guys.